Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed the curved surface area and the total surface area of cylinder, and we have solved first two questions from exercise 13.2. Hope it was clear for you all. In today's session, we shall discuss the remaining problems from exercise 13.2. Let's move on to the topic. Next, we shall discuss the third question from exercise 13.2. A metal pipe is 77 centimeter long. The inner diameter of a cross section is 4 centimeter, the outer diameter being 4.4 centimeter. Find the inner curved surface area. So a metal pipe, as you know, the inside portion is empty. That is called the hollow cylinder. So 77 centimeter long means height is 77 centimeter. And the diameter of the cross section in the sense the top portion or the bottom portion, we can call it as the cross section, that is 4 centimeter inner diameter and outer diameter 4.4 centimeter. How these two radii are coming in the sense we will see it in the diagram. So this is the diagram of a pipe. Here you can see the upper portion, there are two circles, one bigger circle and another one is the smaller circle. Big one is called the outer circle and the inside one is called the inner circle. Diameters are given d1 4.4, d2 4.4 and d1 4 centimeter. The same portion will be there in the bottom also. These two are called the cross sections. And when we look at the pipe from outside, it looks like this. The side view of the pipe is this one. And here let's write the inner radius because we want to calculate the inner curved surface area. Inner radius of the pipe is, here you can see the inside circle. The diameter is given to us 4 centimeter. Radius is diameter by 2, that is 4 by 2 equal to 2 centimeter. Height it is given to us 77 centimeter. Then as we know the curved surface area of cylinder, the formula is 2 pi RH. But here we have to use R1 and R2 because two radii we will get. One is inside one, another one is outside one. So to identify that we have to write it as R1 and R2. R1 is inner radius. 2 pi R1 into H. Let's substitute it. 2 into pi value is 22 by 7. R1 is 2 and H is 77. Here 7 and 77 we can cancel 11 times. So 2 into 22 44. 44 into 2 is 88. 88 into 11 is 968 centimeter square. So two ways you can do the calculation. One is mental calculation. These things small multiplication and all you can do mental calculation. If you feel difficulty, you have to do the rough calculation on the right side of your answer sheet or just right side of this step. So the outer curved surface area is the next question. Outer curved surface area in the sense this outer portion we have to consider. The outer circle we have to consider and this entire portion. This also a cylindrical shape only. The outer radius we have to calculate. Outer radius in the sense R2 we can take, that is diameter divided by 2. Diameter is 4.4 is given to us. 4.4 by 2, that is 2.2 centimeter. That is the outer radius. Next we will go for the outer curved surface area, that is 2 pi R2H. The formula is 2 pi RH. Since we have two radii, we have to use R1 and R2. Here outer one we have considered as R2. So 2 pi R2 into H. Substitute it, 2 into pi 22 by 7 into R2 is 2.2 into height is 77. Here also 7 and 77 we can cancel 11 times. Here this calculation you have to do it on the right side. Just we have to multiply because decimal numbers are there. So 2 into 22 44. 44 into 2.2 into 11. We will get as 1064.8 centimeter square. I repeat, please do not copy this answer, just to do the multiplication on the right side of this step. Next one, we have to find out the total surface area. So for calculating the total surface area, since here there is hollow cylinder, it is given to us. Direct formula we cannot use. So we have to identify the surfaces. Here top there is one face. You can see one more diagram. Here there is top. Yellow color there is portion is there, that is one surface. The same portion will come here also in the bottom also. So two faces and one is the curved face, that is outside. Like that 3 faces are there. So each one we have to calculate, and there is one more face is there, that is inside. Inside is empty. Outside visible one is 3. Here one, top one and bottom one. Total 3, and inside also empty. Since it is a pipe, you can just imagine how a pipe looks like. Inside is also cylindrical portion, it is empty. So that portion also we have to see, and that face also we have to consider. So total 4 faces. Let's calculate the area of this portion. This is quite simple. One is bigger circle, another one is smaller circle. The area which we need to calculate is the shaded portion, that is the yellow color portion. It is bigger circle area minus the smaller circle area. So let's calculate that portion. Area of the base is equal to pi r2 square minus pi r1 square. R2 is the outer radius, so outer radius is the bigger one, and r1 is a smaller radius, so that is the second one we can take. So pi into r2 square minus r1 square, 22 by 7 into, in these two there is pi common that I have taken outside because that is easy for calculation. So 22 by 7 into, inside r2 square minus r1 square will come. R2 square we have calculated here, R2 2.2. So 2.2 square minus R1 we have calculated 2. So 2.2 square minus 2 square, that is equal to 22 by 7 into, here 22 square we know 484. So 2.2 square is 4.84 minus 2 square is 4. That is 22 by 7 into 4.84 minus 4. When we subtract these two numbers, we will get 0.84. 7 and 0.84 we can easily cancel. We will get as 0.12. Here 8 1 times 7 will go, balance 1 42 times. So 0.12. Then 22 into 0.12, you must multiply it. You will get answer 2.64 centimeter square. Here also I am repeating the same thing. Please do not copy, do the rough calculation. Then area of one base we have got. Here we have two bases. One is at the top and another one is at the bottom. Then total surface area we can calculate. The rest of the things are there with us. So we can just add, that is enough to find the total surface area. Total surface area is equal to curved surface area of inner cylinder. When you see from outside, inside portion is empty, it is a pipe. So that is inside portion is a cylindrical portion. That is curved surface area of inner cylinder. We have calculated inner curved surface area plus curved surface area of outer cylinder. When we look from outside also cylindrical portion, curved portion, that we have to add. That is already calculated, outer curved surface area. Then as I mentioned before, 2 into base area. There are two bases are there. One is at the top and another one is at the bottom. Both are same area. So 2 into base area. Let's substitute the values. Curved surface area of inner cylinder we have calculated here 968. Then curved surface area of outer cylinder we have got 1064.8, we have calculated before, plus 2 into base area. Base area we have calculated 2.64. So when we do the calculation, 2 into 2.64 we will get 5.28, and when we add these two we will get 2032.8. So if you are unable to do the mental calculation, just do it as a rough calculation on the right side of this answer. Then when we add these two numbers, 2032 plus 5, then 2038.08. Here decimal portion also is there. 2032.8 plus 5.28, when we add 2038.08 centimeter square. This is the total surface area of cylinder, that is cylindrical pipe. 2038.08 centimeter square. Next, we shall discuss the fourth question. The diameter of a roller is 84 centimeter and its length is 120 centimeter. It takes 500 complete revolutions to move once over to level a playground. Find the area of the playground in meters square. Assume pi is equal to 22 by 7. The value of pi is given to us. A diameter of a roller. A roller you might have seen in cricket ground and football ground and all for leveling the ground. It is used. 84 centimeter is the diameter and length is 120 centimeter. So it takes 500 complete revolutions to move once over to level a playground. You have to find out the area of the playground. So the roller looks like this and it is used for leveling the ground, leveling the playground. And here it is given to us the diameter is 84 centimeter. This is a circular, only this portion we have to consider. This handle and all no need to consider, only the cylindrical portion. So this is a circular portion and the circle is having diameter 84 centimeter and length means this one. Length is 120 centimeter. So one time it is a revolving, or one time it is a rolling, in the sense it is rolling the curved surface area. One time if the roller is rolling over the ground, means we can say that the curved surface area is covering one time. Means we have to find out the curved surface area of this roller. Here, when we draw only this portion, the diagram looks like this. The roller portion, height is 120 centimeter and the diameter is 84 centimeter. This is the shape of a cylinder. And here, roller is of form cylinder, and radius we can calculate a diameter by 2, 84 by 2 is 42 centimeter. And area of the roller is equal to area of roller, that is equal to curved surface area of cylinder. Here how much area it is rolled in one time, in the sense that is equal to the curved surface area of this cylinder, because this curved portion only it is rolling over the ground. So curved surface area of cylinder, we know the formula 2 pi r h. H is here 120 centimeter. Then 2 into pi value is given to us 22 by 7 into radius is 42 into 120 height centimeter square. That is equal to, when we calculate, we can just divide this 7 and 42 6 times. No more cancellation, just a multiplication only. 2 into 22 into 6 into 120. When we multiply, we will get 31,680 centimeter square. So you must do the calculation and verify that you are getting this answer, 31,680 centimeter square. This is the area which is covered when the roller is rolled one time. Here area of one revolution is equal to area of the roller, that is equal to 31,680 centimeter square. We have already discussed this matter. Then here it is given to us 500 complete revolutions the roller is making. That means area of 500 revolution is equal to 1 time 31,680. 500 times, in the sense 500 into 31,680. So that is area of playground. Area of playground is equal to, when we multiply these two, we will get 1584, then 4 zeros. So 1 crore 58 lakh 40,000 centimeter square. It is a huge amount. So but the unit is very small unit, centimeter square. So in order to reduce the size, you have to change this unit. This centimeter square we can change to meter. So centimeter, this is actually the answer, but since it is a very huge quantity or amount, we can reduce when you convert this smaller unit into higher units. So centimeter to meter, we know the conversion, it is divided by 100. Centimeter is a smaller unit and meter is a bigger unit. When you are changing the smaller unit to bigger unit, we have to divide. Here centimeter to meter, in the sense divided by 100. Centimeter square to meter square means 100 square we have to divide. That is the quantity, that is 1 crore 58 lakh 40,000 divided by 100 square. 100 square, in the sense there will be 4 zeros, and that denominator 4 zeros and the numerator 4 zeros can be cancelled, and you will get the final answer as 1584 meter square. So this is the area of playground. Next we shall discuss the fifth question. A cylindrical pillar is 50 centimeter in diameter and 3.5 meter in height. Find the cost of painting the curved surface area of the pillar at the rate of rupees 12.50 per meter square. The value of pi is given to us 22 by 7. Cylindrical pillar, here itself the shape is given to us cylinder, is 50 centimeter in diameter. From here radius we can calculate, and 3.5 meter in height. Height also given to us. You have to find out the cost of painting the covered surface area, covered surface. So cost of painting the covered surface, in the sense, first of all we have to calculate the covered surface area of cylinder or covered surface area of pillar by using the given measurements. Then that covered surface area we have to multiply with the rate, that is 12.50. Then we will get the cost. So the pillar looks like this. The diameter is given to us 50 centimeter and height is 3.5 meter. Very important thing you have to notice is this one, the units. One is in centimeter and another one is in meter. So both we have to convert into same unit. That we will do it while calculation. So pillar is in the form of a cylinder. Height is given to us 3.5 meter. If you want to write height, only height, you can write, it's not a problem. and only radius also not a problem. So radius r of the circular end of pillar is 50 by 2, that is 25 centimeter. If you want to mention only radius, then you can write as it is, it's not a problem. Then here this centimeter we have to change to meter. In the previous question we have discussed centimeter to meter means divided by 100. So r is equal to 25 by 100 meter, that is equal to 0.25 meter. Here in the denominator two zeros are there. So we have to put the decimal 2 digits from the right. So 2 digits from the right means the decimal will come just behind 2. So 0.25 meter. Now curved surface area we can calculate. Since the pillar is in cylindrical shape, curved surface area of cylinder formula we can use, that is 2 pi rh. So 2 into pi value is 22 by 7 into r we have calculated 0.25 into h is 3.5. So here 7 and 3.5 we can cancel it 0.5 times. So no denominator means no division, only multiplication. 2 into 22, 44 into 0.25 into 0.5. You must multiply it and verify that you are getting the answer as 44 into 0.125. 0.1, or else a mental calculation also it is easy. So this 2 you can do it mentally. 2 into 22, 44. 25 into 5, 125. So here 3 digits after the decimal, here 2, here 1. So 0.125. Then you can multiply these two, that is easy. Or else you have to multiply 1 by 1. Wherever mental calculation is possible, that you do it, so that you can save your time. That is 44 into 0.125, when you multiply you will get 5.5 meter square. I repeat again, please do not copy, just to do the calculation on your notebook and verify that you are getting this answer. Cost of painting 1 meter square area is 12.50. That is what the rate given to us. So 1 meter square area for painting cost is 12.50. We have 5.5 meter square area. So the cost of painting 5.5 meter square area is just 5.5 into 12.50. You have to multiply this 5.5 and 12.50. You have to multiply. When you multiply, you will get the answer as 68.75. So this is the cost, rupees 68.75. So the cost of painting is equal to rupees 68.75. Move on to the sixth question. Curved surface area of a right circular cylinder is 4.4 meter square. If the radius of the base of the cylinder is 0.7 meter, find its height. Here also pi value is given to us 22 by 7. This is an indirect question. Curved surface area of right circular cylinder is given to us 4.4 meter square. We know how to calculate the curved surface area of cylinder. The formula is 2 pi rh. So 2 pi rh is equal to 4.4 meter square. And in 2 pi rh, here radius is given to us. R is there 0.7 meter and height is missing, that we have to calculate. So quite simple question. And you have to verify we have to check the units. Here it is in meter square, here it is in meter. So all units are in same. So no need to worry. So this is the cylinder, it is given to us. Radius is 0.7 meter and height is missing, that we have to calculate. Curved surface area is given to us. So height of the circular cylinder we can assume as h. Radius it is given to us 0.7 meter. Curved surface area of cylinder formula we know 2 pi rh. Then curved surface area it is given to us, that is 4.4 meter square. So 4.4 meter square is 2 pi rh. Here let's substitute the given value. That is 4.4 is equal to 2 into pi value is 22 by 7. Radius is given to us 0.7. Height is unknown. According to our assumption, height is h. Then here decimal values are there. Let's just make a rearrangement. That is 4.4 we can write it as 44 by 10. So that it is easy for us to calculate. Because when decimal calculations are there, it takes time. So 4.4 we can write it as 44 by 10. Since here after the decimal only one digit, we have to put 10 in the denominator. Then here also 0.7 is there, that we can write it as 7 divided by 10. After the decimal one digit, so there is 10 in the denominator. Now we can cancel the common terms. On the left side there is denominator 10 and the right side also here denominator 10. Here it is a product, so no need of worrying that whether it can be cancelled or not. It can be cancelled because left side one single quantity, right side it's a product, so we can cancel the common denominator. Here 10, here 10, that can be cancelled, and here there is a 7 and here there is a 7 in the numerator, so that also can be cancelled. Now balance is 44 is equal to 2 into 22 into h. That is what the balance. From here h we can calculate. Here this 2 into 22, it is a product that we can bring to the left side, means it comes as the denominator. When multiplication comes to the right side or left side, it changes division. So 44 divided by 2 into 22. Here 2 into 22, we know that it is 44. 44 by 44 is quite simple, it is 1. So the unit is meter. So the height of the cylinder is 1 meter. Next we shall discuss the seventh question. The inner diameter of a circular well is 3.5 meter. It is 10 meter deep. Find its inner curved surface area. That is first question. The cost of plastering this curved surface at the rate of rupees 40 per meter square. Here pi value is given to us 22 by 7. The inner diameter of a circular well is 3.5 meter. We know what is well. It is 10 meter deep. So diameter is given to us, depth or height is given to us. Always well is in cylindrical shape. So this is the diagram of a well, and it is water is filled inside, and the diameter of the well is given to us 3.5 meter and the height is 10 meter. Both the units are in same, no problem, same unit. And here what we have to calculate is in its inner curved surface area. As we know, the well is in the shape of a cylinder. The inner curved surface area, in the sense we have to calculate the curved surface area of cylinder. So inner radius is given to us, that is 3.5 is the diameter, 3.5 by 2, that is the radius, that is 1.75 meter. Depth or height of the cylinder or well is given to us 10 meter. Now we have R and H. The shape of the well is in the form of a cylinder. So we have to go for curved surface area. Curved surface area of cylinder is 2 pi RH. That will be equal to the inner curved surface area of the well. That is equal to 2 into pi. Pi value is given to us 22 by 7 into radius. Radius is 1.75 into height is 10. All we have substituted. And here there is a decimal value. Just like the previous questions, let's change this decimal into fraction. That is 2 into 22 by 7 into 1.75. We can write it as 175. So 175 by 100 into 10. So we'll go for cancellation. 7 and 175 will go for 25 times. And this 25 and 100 we can cancel 4 times. And this 2 and 4 we can cancel 2 times. And this 2 and 10 we can cancel 5 times. So only 22 and 5 is the balance in the numerator. So 22 into 5 is 110 meter square. Next is cost of plastering 1 meter square area is given to us 40 meter square. Here cost of plastering this curved surface. So inside the well we are going to plaster it, and the cost of plastering is 40 per meter square. Here plastering, in the sense we are plastering the inner curved surface. So inner curved surface area we have calculated 110 meter square. For 1 meter square we have cost rupees 40. So for 110 meter square area we need to multiply this 40 into 110. For 1 meter square the cost is rupees 40. For 110 meter square, because the curved surface area we have calculated 110 meter square. For 110 meter square, the area, 110 meter square area, the cost is 40 into 110. So 110 into 40, when you multiply, you will get 4,400. So the cost of plastering the curved surface area of the well is rupees 4,400. Move on to question number 8. The question is, in a hot water heating system, there is a cylindrical pipe of length 28 meter and diameter 5 centimeter. Find the total radiating surface in the system. Here also pi value is 22 by 7. It is given to us. In a hot water heating system, there is a cylindrical pipe of length 28 meter and diameter 5 centimeter. Here cylindrical pipe length is given to you, that means height it is 28 meter and the diameter is 5 centimeter. From here we can calculate the radius. Find the total radiating surface in the system. So This is a cylindrical pipe. It is given to us in the heater, and the water will go through inside this pipe, and through, because of the radiation, the water will get heated. Here you have to find out the total radiating surface. The total radiating surface in the sense water will pass through this cylindrical pipe, means it is passing through the curved surface area. So the cylindrical pipe radiates from the curved surface and not from the ends. When the water is passing through inside this cylindrical pipe, the radiation will come from the curved surface only. So the cylindrical pipe radiates from the curved surface and not from the ends. So here we need to find the curved surface area of the cylinder. For that, diameter is there. From here we can calculate the radius. Height is there. So by using curved surface area formula 2 pi RH, we can calculate the curved surface area. So let's write the given things. Height of the cylindrical pipe is 28 meter. It's given here. And radius is diameter by 2. 5 by 2 centimeter. That is 2.5 centimeter. Here one is in meter, another one is in centimeter. So we have to change. So here centimeter to meter changing time 2.5 centimeter. 2.5 centimeter means centimeter to meter is divided by 100. So 2.5 into 1 by 100, that is equal to 2.5 divided by 100 only. Here into 1 by 100 in the sense 2.5 divided by 100. So when you divide it, here after the decimal there is only one digit. Again it is divided by 100, means 2 more zeros. 2 more zero means from here we have to move the decimal 2 digits to the left. 2 digits to the left in the sense only one digit is here, one more digit is required. So we have to put a 0. So 0.025 meter. So now centimeter is changed to meter. Next is the total radiating surface in the system, that is equal to CSA of the cylindrical pipe. It was already explained. Water is passing through this cylindrical pipe. The radiation is from the curved surface. So curved surface area of cylindrical pipe we need to calculate. That is formula 2 pi RH. That is 2 into 22 by 7 into R. Radius we have converted and kept here 0.025 into height is 28 meters. So that is what it is written here. Now we can cancel this 7 and 28. Easy to divide. That is 7 4s are 28. Now 2 into 22, 44 into 4 into 0.025. When you multiply these four quantities, you should get 4.4 meter square. Once again, I repeat, please do not copy, do the multiplication and verify that you are getting this answer. So the total radiating surface in the system is 4.4 meter. Next, we shall discuss question number 9. Find the lateral or curved surface area of a closed cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter high. Pi value is given to us 22 by 7. We are asked to find out the lateral or the curved surface, both are same, of a closed cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter high. Closed tank, storage tank, you might have seen in petrol pump and all, it is underground storage. Usually the shape is cylindrical and 4.5 meter is the height here and the diameter of the tank is 4.2 meter. So we are asked to find out the curved surface area. So let's write the given things. Height is equal to 4.5 meter and radius is diameter by 2, 4.2 by 2, that is 2.1 meter. It is a direct question. Just we can calculate the curved surface area by using the formula 2 pi RH, that is 2 into pi 22 by 7 into R. Radius is 2.1 meter. The height is 4.5 meter. As before, let's change this decimal into fractions. 2 into 22 by 7 into 2.1 we can write it as 21 by 10. 4.5 we can write it as 45 by 10. Go for a little bit of cancellation. 7 and 21 we can cancel 3 times. And denominators are multiples of 10. Here also 10 and here also 10. Let it be there. No need to go for cancellation. And we can easily divide a numerator with 100. So 2 into 22 into 3 into 45, that is 2 into 22 into 3 by 10 into 45 by 10. Then let's multiply the numerator, that is 45 into 3. When you multiply you will get to 135 and 135 you have to multiply with these 2 into 22, that is 44. 135 into 44 when you multiply you will get 5940. This is the way you have to show the rough calculation. Just the right side of your answer. So that is equal to 5940 divided by here 10 into 10 100. 100 in the sense two zeros. Means we have to move the decimal from the right to left two decimal places. So two digits we have to move. So decimal will come between 9 and 4. So 59.4 meter square is the curved surface area of tank. Next, we shall discuss the second part. How much steel was actually used if 1 by 12 of the steel actually used was wasted in making the tank. Assume that pi is equal to 22 by 7. Here, how much steel was actually used? Some quantity is already wasted. 1 by 12 of the steel actually wasted in making the tank. So let's recall the shape. This is a cylindrical tank. Height is 4.5 meter. Diameter of the base is 4.2 meter. In the previous slide we have calculated, or we have written, h is equal to 4.5 meter and the radius is 2.5 meter. Since it is a closed cylindrical tank, for keeping the petrol it is making, and since it is closed at the top, it is the total surface area of the cylinder we have to calculate. Means upper surface also we have to calculate, bottom surface also we need to consider, and the curved surface also we need to consider. So for making this tank, all the three surfaces we have to calculate the area. That means total surface area of the tank will be equal to the total surface area of the cylinder, that is 2 pi r into r plus h. Let's substitute this 2 into 22 by 7 into r is 2.1 meter into r plus h, 4.5 and 2.1. Let's substitute it, 2.1 plus 4.5. Let's add these two which is inside the bracket. 2 into 22 by 7 into 2.1 into 2.1 plus 4.5. When you add, you will get 6.6. Now let's make these two decimals as fractions. That is 2 into 22 by 7 into this 2.1 we can write it as 21 by 10. 6.6 we can write it as 66 by 10. It was already explained. So after the decimal there is one digit, so we put 10 in the denominator, and in the numerator we avoid the decimal part. That's all. Let's cancel it. 7 and 21, it is 3. Now denominator 2 10s are there, let it be there. It is easy to divide. No need to cancel. Just multiply the numerators. That is 3 into 66. When you multiply, you will get 198. Then that 198 you have to multiply with 2 into 22. That is 44. When you multiply 198 and 44, you will get us 8712. Divided by this 100. 100 in the sense 2 zeros in the denominator. Means we have to move the decimal from the right end to the left two digits. So here between 7 and 1 the decimal will come. Here there are two zeros. So we have moved two places to the left. That is 87.12 meter square is the answer. That is the total surface area of the tank. Some conditions are given to us. By using that condition, we have to find out how much steel was actually used. So let the amount of steel used in making the tank was X. Let it be X. Then steel wasted is 1 by 12 of the steel actually used. So 1 by 12 of actually used quantity is X. So steel wasted is equal to X divided by 12. Given that the amount of steel required minus the amount of steel wasted is equal to total surface area of the tank. So amount of steel required minus amount of steel wasted. Amount of steel required is X. This is the X amount of steel required one minus the wasted one. X by 12 amount is wasted. When we subtract these two, it should be equal to the total surface area of the tank. That is 87.12. Once again, it is from the given statement we are writing. Amount of steel required, some quantity is actually required, and some we have wasted. Wasted means it is of no use. So minus that wasted amount will be equal to the actual quantity. Actual quantity is equal to the total surface area of the tank. This is the actual quantity. So actual quantity we have already calculated, 87.12. That will be equal to the total surface area of the tank. So from here X we have to calculate 12 into X, that is 12X minus X. LCM we are taking. 12X minus 1X is 11X. So 11X by 12 is equal to 87.12. Then X is equal to, here the numerator will come to denominator, and denominator will go to the numerator. That means 87.12 into the reciprocal of this one, that is 11 by 12. When it is coming to the right side, it becomes 12 by 11. That is 12 will come here. 12 into 87.12 divided by 11 come in the denominator. That is, this 11 and 87.12 you have to divide. I am writing only the answer here, so you have to divide and check. 7.92 you will get. Please do not copy, just do the calculation like this on the right side, division. Then you have to multiply this 7.92 and 12. When you multiply these two, you will get as 95.04 meter square. That is the value of X. Actually, what is X in the sense? Amount of steel used in making the tank. That is, the amount of steel used in making the tank is 95.04 meter square. In a sentence, if you write 95.04 meter square steel was used in actual while making such a tank. Now let's discuss question number 10. In the given figure, you see the frame of a lampshade. It is to be covered with a decorative cloth. The frame has a base diameter of 20 cm and a height of 30 cm. A margin of 2.5 cm is to be given for folding it over the top and bottom of the frame. Find how much cloth is required for covering the lampshade. Pi value is given to us 22 by 7. So in the given figure, you see the frame of a lampshade. It is to be covered. The lampshade is to be covered with a decorative cloth. The frame has a base diameter of 20 cm. From here we can calculate the radius. Height of the lampshade is given to us 30 cm. And here we have to keep a margin for folding it properly, that is 2.5 cm. Let's see the given diagram. So lampshade is like this. It's in cylindrical in shape and height is 30 cm, diameter is 20 cm. And how it should be covered? In the sense, this way it should be covered. 2.5 cm margin we have to keep for folding it over the top and bottom. Top and bottom for covering, you should keep it 2.5 cm margin. Means actual height is 30 cm. This is 30 cm. And from here top it is 2.5 cm kept extra, and bottom also 2.5. Means total 2.5 plus 2.5, 5 cm height you added extra for covering this lampshade with cloth. That is, height will change to 30 plus 2.5 plus 2.5, that is equal to 35 centimeter. Means here up to here we have to cover, but for folding purpose we have to keep 2.5 centimeter extra. Top 2.5 centimeter, bottom 2.5 centimeter. That means total 5 centimeter you have to add extra. So height will change from 30 to 35 centimeter. And the diameter remains the same only. Diameter is 20 centimeter because you have nothing to do with the diameter. Then cloth is in the form of a cylinder because we are covering the cylindrical shape. So the cloth also, of course, it should be in the shape of cylinder. Height is 35 centimeter. It is already explained how this 35 centimeter has come. Radius, no change, that is 20 by 2, 10 centimeter. Here, area of cloth required is equal to curved surface area of cylinder. Curved surface area of cylinder in this, because we are covering the covered portion only. So covered portion means curved surface area of cylinder. Curved surface area of cylinder formula is 2 pi RH. 2 pi RH, just substitute the values, that is 2 into pi value is 22 by 7 into R, radius is 10 into height is 35. Let's cancel it, 7 and 35, it will go 5 times. Then 22 into 2 into 10 into 5. When you multiply it, you will get the answer as 2200 centimeter square or 2200 centimeter square. So the area of cloth required is 2200 centimeter square. So that we have to write it as conclusion. Now let's discuss question number 11. The students of a Vidyalaya were asked to participate in a competition for making and decorating pen holders in the shape of a cylinder with a base using cardboard. Each pen holder was to be of radius 3 cm and height 10.5 cm. The Vidyalaya was to supply the competitors with cardboard. If there were 35 competitors, how much cardboard was required to be bought for the competition? Here, the students of a Vidyalaya were asked to participate in a competition. The competition means they are making and decorating pen holders. Shape is cylindrical with a base. So, using cardboard, they are going to make, and each pen holder was to be of radius 3 centimeter and height 10.5 centimeter. So cylindrical shape, radius and height is given to us. The Vidyalaya was to supply or to provide cardboard for making. So there are 35 people to participate. How much quantity of cardboard required for making these 35 pen holders? That is what the question. So the pen holders, the shape of the pen holders is just like a cylinder, and the base portion is there with a base in the sense this portion at the bottom. Here it should be open because it is a pen holder. You have to keep the pen inside, and this portion will be open, and this portion is there fixed. That is the base. So base means this also with a radius 3 centimeter. So the pen holder means how many surfaces are there, we have to count first. This is open, the top portion is open because we have to keep the pen inside. Curved portion is there, curved surface area is there, and the bottom also is there. So curved surface area of cylinder plus area of this circle. This is the total surface area of this pen holder. So that is what we have to. So surface area of one pen holder is curved surface area of cylinder with a base plus area of circle with a radius 3 centimeter. This one, because this 3 centimeter circle radius we have to fix it at the bottom. So curved surface area of cylinder we know 2 pi RH plus area of circle with radius 3, that is area of circle pi r square formula. So this is the surface area of one pen holder. You have to substitute these values R and H values here, then you will get the surface area of one pen holder. When you multiply the surface area with 35, you will get the surface area of 35 pen holders. So that will be your answer. So 35 people cardboard they have to buy. So the quantity of cardboard required for 35 people, in the sense this area means area of one pen holder into 35. So this portion or this question you will do it as homework. Dear students, today we have discussed question number 3 to 11 from exercise 13.2. Hope it is clear for you all. I request all the students to solve these questions independently in a sheet of paper, and while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.